and that's what these are. What I do is I run a end mill around the inside of there, 12mm down. This is 12mm plate, don't forget, because I make these slightly bigger than what the hole is in here, because the hole isn't actually square. You have to make it square. And I make a ledge there. There's about a 1 to 1/2mm ledge all the way around there. But I still make it so this is a fairly tight fit in here. Okay, it'll sort of nearly go in. So it is necessary to now use a leather or rubber hammer or a block of wood on here. I like a nice tight fit, which this is, and slightly proud, about 1/2mm proud, which is what I also like. So now what I'm going to do is 4 set screws, countersunk set screws around the outside. However, I didn't actually think of this at the time of doing the drawing, but I can't put them dead on center here because I'm going to run into that hole there, so I'm going to have to go slightly off to one side. I don't think it'll look that odd. I think it's going to be effective anyway. So, and just be careful, if you do put an oil groove in, just be careful you don't put it next to this oil groove. So actually I'll go this side, and I just have to put a nick in here, or I could put a drill in here and thread it and put a grub screw for the oil way. Can't make my mind up what I'm going to do about that yet. And the reason I'm putting an oil way in is because I use a brass thrust bearing in here. I mean, you can buy thrust bearings, races, and this, that, and the other, but I like to do stuff myself. And it's an old-fashioned way, 50, 60, 70 years ago. That's how it was done. You use either phosphor bronze or brass thrust washer, and it worked then. So if I can make something, I will. What I'm doing now is I'm actually countersinking with a 5mm drill, and I'm just drilling a hole just through the outer casing part, and then the thread will be down in through here. So these will drop in there like so through. It's got a 5mm hole there, so these will go through just, and then the threaded part is in here. So that's what I'm doing at the moment. And I'll just zoom you in for a bit of a better look here. And this is just a simple jig. Now, anything you make to hold something or to assist you to do a better job, it's called a jig. And this really is, this is the fence here. This is just a piece of wood put up against the fence to fetch the material out from the fence, so the chuck doesn't go into the top of the fence or anything like that. And it's also a measured distance you know, sort of holds this into a measured distance underneath the drill, and you just got two stop blocks here which are snugly fit in, which just holds this. I mean, it's as good as a vice, and it presents the material to the drill in exactly the same position every time. So you can see that I've actually drilled the holes off center from the main attachment holes there, and I've done the same for both sides, although this side doesn't really need it. I've done it anyway because the attachment holes for the stepper motor in the corners, but that doesn't really matter. Okay, now I've got this in place pretty well exactly where I want it. It's exactly lined up with this, but what I'm going to do is I'm putting M6 bolts in here. So I've got a 5mm drill, actually a 4.9mm drill, which I'm going to drill into the cast iron and just mark these holes. And at the other end of the lathe, I've got clamped to the bench a block of wood so it doesn't slide off the bench. So I'm going to put quite a bit of pressure on this to get into it, I think. So here we go. Because it's gone all the way through. That's gone through about 10mm thereabouts of cast iron. It hasn't moved, and what I'm going to do is I'm going to drill these out an additional extra size. I'm probably going to go to 7mm, which will allow me some movement here to line up perfectly. Actually 6.5mm would be fine, I think. One. So what I'm going to do now is stick a drill in here to hold it while I move the clamp. I'm going to be really fond of that one. So what I'm going to have to do is drill and tap these first and screw them on. Then drill that one out. That's okay. No need to do it up too tight at the moment. And this isn't the final fitting here. Just do them up firm. Final fitting will be after the bearing's been put in, and we're lining the shaft up with it, and we're bringing the shaft in, and then we can tighten all these up. Well, that's basically on there. Next job. Oh, wait a minute. And that fits on there like that. So I'm going to have to take a little bit off of these. It's not quite. It's going to be very close, but it's not quite fitting in there. So I'm just going to take a little bit off these just a nick off them. I knew it was going to be close. So now the moment of truth. I've set the, I think they call it gibs, up in here as well. They're all done now. So let's bring this up to where, about there, it needs to be. I've got the bearing in here now. Okay, it looks like it's going to go on without a hitch. So all my calculations were correct. I can breathe a sigh of relief now. I've learned over the years you take a bit of time in working things out in your head, and you know, you measure 3-4 times before you actually make a cut or make a part, and invariably it turns out okay. So now I can tighten them up. Okay, so I can tick that part off now on the drawings, and of course the test is being able to turn this by hand, and the cross slide, well, not cross slide, the saddle is actually traversing, you know, traversing down. You can turn it by hand like this, which means you've got everything right. Well, I'm happy with that. I'm really happy. So now I have spacers and what have you to go in here now. Oh, and of course a thrust washer, which, looking at that, I think I need to maybe pop the bearing in a little further to give me a bit of room, but that's fine. That's looking good.